How vast is the universe, and does it end at some ultimate wall that marks its edge? Today, let us embark on an imaginative yet firmly grounded journey through the cosmos, drawing from the most current scientific insights. We will leave behind our tiny blue planet, soar through the solar system, traverse the Milky Way, cross immense superstructures, and approach the farthest observable boundaries. There, the deepest secrets of existence await, whispering of origins, infinities, and the fragile spark of life amid endless darkness. This exploration is not mere speculation, it is anchored in observations from telescopes like Hubble, Planck, and the James Webb Space Telescope, revealing a universe that expands faster than we once thought, driven by mysterious forces that challenge our understanding. Our voyage begins close to home, with the Moon, Earth's silent companion, hanging in the velvet night like a scarred pearl. In 1969, humanity achieved what once seemed impossible. Neil Armstrong stepped onto its dusty surface, his boot imprinting a mark that remains untouched even now, more than half a century later. The Moon lacks any atmosphere, so no winds howl across its craters, no rains erode its regolith. Those footprints could endure for millions of years, a quiet testament to our curiosity, etched into a world of eternal stillness. Imagine the crunch of lunar soil underfoot, the profound quiet broken only by your own breathing, as you gaze back at Earth rising like a blue marble in the black sky, reminder of how interconnected yet isolated we are. As we drift farther, Venus emerges, a shimmering beacon that hides a hellish reality. Often called Earth's twin in size, it is a world of extremes, its atmosphere composed of 96% carbon dioxide, creating a blanket so thick that the surface pressure is 93 times that of Earth, enough to crush a submarine like a tin can. This runaway greenhouse effect traps heat relentlessly, pushing temperatures to 467 degrees Celsius, hot enough to melt lead. Though Venus orbits farther from the Sun than Mercury, it claims the title of the hottest planet in our solar system. Picture standing there, if you could. The air would feel like a suffocating fog, laced with sulfuric acid clouds that rain acid droplets, evaporating before they touch the scorched ground. Yet, beneath this inferno, Venus holds clues to climate gone awry, a cautionary tale for our own world as we grapple with rising temperatures. Next, we approach Mercury, the swift messenger of the gods, the smallest planet and closest to the Sun. Its thin atmosphere offers no shield, leading to wild temperature swings. During the day, surfaces bake at 430 degrees Celsius, while at night, they plunge to minus 180 degrees Celsius. From Mercury's vantage, the Sun looms 3 times larger than it does from Earth, a blazing orb dominating the sky. Inside that star, billions upon billions of nuclear fusion reactions rage every second, fusing hydrogen into helium and releasing the energy that warms our worlds. But even this colossal furnace has a finite life. In about 5 billion years, the Sun will exhaust its fuel, swelling into a red giant that could engulf the inner planets, including Earth. Feel the stark contrast, the searing heat on one side, the biting cold on the other, as Mercury hurtles through its orbit, a barren rock scarred by craters, whispering of the Sun's eventual demise. We pause now at Earth, our fragile oasis, the only known harbor of life in this vast expanse. Orbiting at an average distance of 150 million kilometers from the Sun, a span defined as 1 astronomical unit, Earth receives sunlight that takes 8 minutes and 20 seconds to arrive. That light bathes our oceans, nurtures vast forests, and touches every living thing, sustaining a delicate balance. Imagine the gentle warmth on your skin, the rustle of leaves in a breeze, the distant crash of waves, the symphony of a living planet. Yet, in the grand scale, Earth is a speck, its biosphere a thin veil clinging to rock, vulnerable to cosmic whims. Venturing outward, Mars greets us, the Red Wanderer, a cold and arid realm that once may have teemed with possibilities. Though now a dusty desert with temperatures dipping to minus 60 degrees Celsius on average, evidence abounds of a wetter past, ancient river valleys carved by flowing water, massive volcanoes like Olympus Mons towering 21 kilometers high, and polar ice caps holding frozen water. Scientists believe Mars lay in the habitable zone billions of years ago, with lakes and perhaps even oceans. Recent findings from NASA's Perseverance rover and the Mars Reconnaissance Orbiter suggest subsurface water ice and organic molecules, fueling dreams of future human colonies. Envision walking those rusty plains, the thin air whispering of lost rivers, the faint hope of life stirring beneath the soil, evoking a sense of melancholy for what might have been, and what could yet be. Passing through the asteroid belt, a chaotic ring of rocky remnants from the solar system's birth, we encounter Jupiter, the gas giant king. Without a solid surface, it is a swirling cauldron of hydrogen and helium, where storms rage eternally. The Great Red Spot, a colossal anticyclone observed for at least 350 years, spans 16,350 kilometers, wide enough to swallow 2 to 3 Earths. Winds howl at 432 kilometers per hour, painting a vortex of crimson clouds. Jupiter's immense gravity shapes the solar system, flinging comets away or drawing them in, a guardian and destroyer. Sense the thunderous roar of its atmosphere, the electric crackle of lightning 1,000 times stronger than Earth's, as we marvel at this behemoth's raw power. Farther still, Saturn captivates with its iconic rings, vast halos composed of billions of icy particles, from dust grains to house-sized boulders. These rings, remnants of shattered moons or comets, stretch hundreds of thousands of kilometers but are mere meters thick in places. In 2013, NASA's Cassini spacecraft captured a poignant image. From nearly 1,400,000,000 kilometers away, Earth appeared as a pale blue dot nestled beside Saturn's grandeur, a humbling view that stirred global emotion. Carl Sagan once reflected on the dot as containing everyone who ever lived, a call to cherish our shared home. Hear the silent shimmer of those rings, like cosmic whispers, as Saturn's hexagonal storm at its north pole swirls mysteriously, a geometric enigma in the gas. Beyond lie Uranus and Neptune, the ice giants, cloaked in deep blue hues from methane in their atmospheres, which absorbs red light and scatters blue. Uranus tilts wildly on its side, perhaps from an ancient collision, rolling through its orbit like a toppled sphere. Neptune's winds scream at 2,000 kilometers per hour, the fastest in the solar system, whipping dark spots across its face. These worlds, rich in water, ammonia, and methane ices, evoke a sense of alien chill, the distant hum of supersonic gales, the faint glow of internal heat piercing the cold. Together, these 8 planets, along with dwarf planets like Pluto and countless asteroids, comets, and moons, form our solar system, a family orbiting a single star. But as we zoom outward, the sun fades to a dim spark amid a sea of stars, each potentially hosting its own worlds. Exoplanet hunters, using telescopes like Kepler and TESS, have confirmed over 5,500 worlds beyond our system, some inhabitable zones where liquid water might exist, igniting wonder about life elsewhere. Expanding our view, we encompass the Milky Way, our galactic home, a barred spiral containing between 100 billion and 400 billion stars, with a diameter of about 100,000 to 200,000 light-years. Earth resides in the Orion Arm, a minor spiral branch, far from the bustling core where a supermassive black hole, Sagittarius A, lurks with 4 million solar masses. On clear nights, the Milky Way appears as a hazy band, but it is a vast disk of stars, gas, and dust. Recent Gaia mission data maps billions of stars, revealing streams of ancient mergers, like the Gaia sausage, evidence of galactic cannibalism. Feel the slow whirl of this cosmic carousel, stars born in nebulae like glowing cradles, dying in supernovae that seed new generations. 2.5 million light-years away lies Andromeda, our nearest large neighbor, a spiral boasting 1 trillion stars. It hurtles toward us at 300 kilometers per second, destined to collide with the Milky Way in 4.5 billion years, merging into a new galaxy dubbed Milkomeda. Yet, space is so vast that stars will rarely crash, instead, they will dance into new patterns. Andromeda and the Milky Way anchor the local group, a collection of about 50 to 134 galaxies, mostly dwarfs, spanning 10 million light-years. This local group is but a suburb in the Virgo Supercluster, housing around 100 galaxy groups and clusters, a web of 2,000 galaxies stretching 110 million light-years. Gravity binds them loosely, yet dark matter, invisible mass making up 27% of the universe, holds the threads, inferred from galaxy rotations that defy visible matter alone. Theories posit dark matter as weakly interacting particles, like actions or WIMPs, eluding detection yet shaping cosmic architecture. Zooming farther, we enter Laniakea, Hawaiian for immense heaven, a supercluster encompassing 100,000 galaxies across 520 million light-years, with a mass of 100 quadrillion suns. Defined by galaxy flows toward the Great Attractor, Laniakea reveals the universe's large-scale structure, filaments, walls, and voids like cosmic foam. The Sloan Digital Sky Survey maps these, showing how gravity and dark energy sculpt the void. As we push to the limits, we peer into the past, for light travels at a finite speed. Sunlight reaches us in 8 minutes, Andromeda's glow in 2.5 million years. The observable universe spans 93 billion light-years, its edge not a wall but a horizon, the cosmic microwave background, CMB, relic radiation from 380,000 years after the Big Bang. Planck satellite data dates the universe at 13.8 billion years, with the CMB a snapshot of hot plasma cooling to 2.7 degrees Kelvin today, uniform yet with tiny fluctuations seeding galaxies. At this boundary, we confront the Big Bang, 13.8 billion years ago, singularity of infinite density and temperature expanded, birthing space, time, and matter. Not an explosion in space, but of space itself. The James Webb Space Telescope, JWST, launched in 2021, peers deeper, spotting little red dots, early supermassive black holes and massive galaxies defying models, suggesting rapid formation via direct collapse or mergers. JWST also reveals blue monsters, ultra-compact bright galaxies in the infant universe, and confirms dark energy accelerates expansion, comprising 68% of the cosmos, perhaps vacuum energy or quintessence. Yet, is this the end? Theories suggest no ultimate wall. The universe may be infinite, or curved like a hypersphere. Dark energy drives eternal expansion, potentially leading to a big rip where galaxies tear apart. Multiverse ideas arise from eternal inflation, our universe one bubble in a frothing sea, each with different constants. String theory's landscape posits 10 to the 500 vacua, anthropic principle explaining our fine-tuned laws, why the cosmological constant is tiny, allowing structure. Evidence? CMB anomalies like cold spots hint at collisions with other universes, though debated. Social media buzzes with speculations. Physicists like Sabine Hossenfelder discuss many worlds interpretation, where quantum branches create infinite realities, potentially infinitely larger. Ex-posts ponder cosmic cracks, domain walls from phase transitions post-Big Bang, energetic boundaries warping space. Others invoke black holes as universe seeds, birthing multiverse via cosmological natural selection. Standing at this edge, the universe's immensity evokes awe and humility. Earth vanishes into insignificance. If it winked out, the cosmos would scarcely notice. Amid this vastness, our existence begs purpose. Perhaps, as quantum theories suggest, consciousness navigates realities, dreams glimpsing parallel branches. Or, in biocentrism, life shapes the universe. The mystery stirs curiosity, a drive to explore the unknown, finding meaning in the quest itself. In closing, we extend heartfelt gratitude to the scientists whose tireless efforts illuminate these wonders. To Neil Armstrong and the Apollo teams, thank you for bridging worlds with courage. To the Venus and Mercury mission pioneers, your probes unveiled harsh truths, honoring exploration's risks. For solar physicists studying our sun's fusion and fate, your dedication sustains our understanding of stellar life cycles. Mars explorers at NASA, including Perseverance's engineers, we appreciate your persistent search for habitability's echoes. Jupiter and Saturn observers, from Galileo's first glimpses to Cassini's grand finale, your insights into gas giant storms and rings inspire humility. To those mapping Uranus and Neptune's icy atmospheres, thank you for revealing distant blues. Astronomers charting the Milky Way with Gaia, your mappings honor galactic evolution. For Andromeda and local group researchers, your collision predictions remind us of cosmic impermanence. Virgo and Laniakea definers, like our Brent Tully, your flow analyses weave the large-scale tapestry. Planck mission scientists, or CMB precision dates creation, profound thanks for Big Bang evidence. JWST teams, uncovering early black holes and galaxies, your discoveries reshape origins, we cherish your innovation. Dark matter and energy theorists, from Vera Rubin to Adam Rees, your invisible pursuits bind reality, gratitude for unveiling expansion's drivers. Multiverse proponents like Alan Guth and Andre Linder, Your inflation models expand possibilities, we value your bold visions. To all, from Hubble's legacy to quantum interpreters like Hugh Everett, your silent devotion advances knowledge, enriching society with wonder and truth.